So welcome all. Today we are understanding something about mutual exclusion. We will try to understand this mutual exclusion in a distributed environment. So one thing that we have to understand what the problem is. The number of processes in a distributed system want exclusive access to some resources. So what we can do, there can be two types of solutions. One can be permission based, one can be token based. So in permission based, what will happen, a process which is wanting to enter into its critical section or access a particular resource, it will ask for permission from all other processes. If it gets the permission, then they can access the resource. And when if all the processes are not giving the permission, it has to wait. Another thing is token based, that a token is passed between the processes, and once the token is received by a process, this process can go in critical section, and once its work is over, then it can pass the token to other one who is interested. Very simple, but how this thing can be implemented. So if at all it is permission based, you can see what we can do. Assume here process P0, P1 and P2 are there. Now P1 is asking some coordinator, okay, for permission to access a shared resource. Now the thing is, if you are using a simple coordinator, like in place of asking all the processes, it is better let us have a coordinator, and if you have a coordinator, then in that case you will have to ask the coordinator only, right? So if you are asking the coordinator, then coordinator will maintain a queue. So this you are asking the coordinator, this P1 asks the coordinator for permission to access a shared resource. Permission is granted, and then process P2 then asks for the permission for the same resource. Now what we are doing, since C is aware that this particular resource is being used, so it keeps 2 in the queue and do not reply anything to P2. Later on, when P1 releases the resource, then it sends the reply to P2 that now you can use the resource. So this is very simple thing in permission based thing. And another algorithm here, you can see what happens is, you would have seen the Lamport algorithm. A little different from there is the acknowledgement are not sent actually. So what you have to do, return a response to a reply only when these things happen. What things? The receiving process has no interest in the shared resource, okay, or the receiving process is waiting for the resource but has lower priority. So you can compare the time stamps for getting the priority, that can be done. So in all other cases, reply is deferred, implying some more local administration. So this is how Ricard and Agrawal algorithm works. What happens is, suppose you have these 3 processes 0, 1, 2, okay. So now 2 processes, suppose they want to access a shared resource at the same moment. In that case, suppose P0 has a lower timestamp, so the one who is having a lower timestamp, they will win the resource, win the competition and access the resource. So when process P0 is done, then it sends a OK message to the next whoever is waiting. Suppose P2, it will send the message. So now also P2 can go ahead. That is the way this Ricard algorithm will work. Now let me tell you something about token ring algorithm. What will happen in token ring that we will organize these processes in a logical ring, and the token will be passed between them. So the one process which is holding the token, they will enter a critical section, and once their work is over, they will pass it to the other. That is the thing. This can be a possible way. So now if at all there are something called decentralized mutual exclusion, what we will do? See, assume every resource is replicated n times, with each replica having its own coordinator. So what the thing is, we want to access the resources. So this access requires a majority voting from m coordinators. There are n replica, you understand. So m is, a small m is greater than n by 2, at least half or more than half, I should say, more than half coordinators. So a coordinator always responds immediately to a request, don't worry. Now what is the assumption? When a coordinator crashes, it will recover quickly, but will have forgotten about the permissions it had granted. So one thing you can understand here about this decentralized mutual exclusion. So if we are comparing these algorithms, whether they are centralized or distributed token ring or decentralized, so what will happen, we will see the values of messages per entry or exit and delay before entry. So for centralized it is 3 and 2, for distributed it is 2 into n minus 1 in both the cases, and for token ring you see messages per entry it is 1 to infinity, and delay before entry it is 0 to n minus 1. Decentralized it is this value, you can see 2 into m into k plus m, where k is 1, 2 to so on, and the delay will be 2 into m into k. So this is something you can remember. Now if we see something about election algorithms, so we have to see whether how the coordinators are elected. Since in the algorithms till now we have seen we need some coordinators. So for these coordinators we will need some ways how to select these, I should say elect these coordinators. Basically, if we are manually selecting one of them as coordinator, it is okay, but it is manual. However, if we want this to happen dynamically, means I should say automatically among the processes themselves, then it is better for us. So actually we want this to happen dynamically, I should say automatically, and that process which happens automatically, we are calling it election. That automatically they will elect one of them as a coordinator. So how this can be done? Okay, if a coordinator is chosen dynamically, to what extent can we speak about a centralized or distributed solution? Okay, is a fully distributed solution, that is one without a coordinator, always more robust than any centralized or coordinated solution? You have to consider these things and think about it. But till now what we are moving further, and assuming these few things, that all the processes have a unique ID, all processes knows IDs of all other processes, and election means identifying the process with the highest ID, that is up, means process is running. So two algorithms that we are going to see. First is a bullying algorithm, which says that we will elect by bullying. So we will consider n processes which are p0 to pn minus 1, and let id of these pk is k. So when a process pk notices that a coordinator is no longer responding to requests, so it itself can initiate the election. This pk can send an election message to all processes with higher identifiers and wait for their response. So the higher identifier processes, if they are responding, it is okay. If they are responding, then we will see here. If they are not responding, then in that case this pk will become the coordinator. If they are responding, then the one who responds will take over from there, and it will send the election message and become a coordinator. That is the thing. So see an example. What happens? Suppose 4 notices that 7 is not responding. So what it does, 4 sends the election message to others, 5, 6 and 7, right? 7 is not working, it is okay. 5 and 6 says that okay, you become the coordinator, no problem. Okay means it responds. So if it responds, means 5 and 6 are ready to become coordinator. So 5 and 6 both sends the election message. 5 sends to 6 and 7. 6 sends to 7. 7 doesn't respond to 6. However, 6 responds to 5. So after that 5 settles down. However, 6 took over, and 6 doesn't have received any message from others. So what happened? 6 became the coordinator and sends the broadcast that I am coordinator, right? So this was election by bullying. Now something that we have to see is election by election in a ring. So here it is priority based. So in a ring you will find out which are the processes which are up, and among them whose priority is more, it will become the coordinator. Very simple. So what will happen? Any process can start the election. It will send the election message to just its successor. If the successor is down, then the next successor. So if a message is passed on, the sender adds itself to the list, and when it gets back to the initiator, everyone had a chance to make its presence known. So everyone lists its name that they are in the list, that I am present. So initiator now sends a coordinator message around the ring containing a list of all living processes. Okay, so the one with the highest priority is elected as coordinator. So suppose here they have initiated. It can be initiated by anyone. Here suppose 6 has also initiated, 3 has also initiated. So what happens? 6 lists its name and sends to 0 0. Then it is 6 0. Then it is 6 0 1, 6 0 1 2, 1 2 3, and so on. When it reaches back, it has all the names of all of the processes which are up. Similarly, the message of P3 was also received as all the processes which are up, and among these which are the process which is having highest priority, it will become the leader. Very simple. This is what you have to learn here in these election algorithms. Okay, so this is what you have learned today about the mutual exclusion and these election algorithms. Thank you.